Well, hello again, ladies and gentlemen. All right, so this is going to be the last day of proving quadrilaterals. Okay, now we're going to be, yesterday was using special quadrilaterals as givens so we know their properties and how can we use those properties. Okay, now this is going to be proving special quadrilaterals. Okay, so again, you're going to need to know all those properties that are listed in this pathway to success for parallelogram proofs. Okay, second page. Okay, now it is that we are trying to prove a rhombus or prove a rectangle or prove a square. Okay, so these are the different methods for being able to do that. Okay, so just be aware that for the rhombus and the rectangle and the square, the first thing it has to be is a parallelogram first. Okay, for all of these things to be true, they have to be parallelograms first. Okay, parallelogram first and parallelogram first. So if you can't um, prove that it's a parallelogram, you can't just go directly to these properties. Okay, it's got to be a parallelogram first. Okay, so um, I'm going to show you a couple examples. Okay, how you can approach these. You might see a couple of new ideas. Okay, but keep in mind every proof is unique. Okay, so you're just going to have to look at it and figure out what properties of each of these special parallelograms you can use to prove them. Okay, so I'm going to start off with this. Okay, our given is actually that ABCD is a rhombus. Okay, and we've got two other sets of sides segments that are congruent to each other. Okay, and what that leads us to is that with those givens and the fact that ABCD is a rhombus, AB and BC are also congruent to each other, making those two triangles congruent to each other. Now we're trying to prove ABCD is a square. So what makes a square a square? Well, it's a rhombus with right angles in it, or even just a single right angle. As soon as there's one, as if it's a rhombus first, if there's a single right angle, then it's got to be a square. Okay, so we've got the two triangles congruent. I'm going to say angle ABL is congruent to angle C. Those are um, the two corners, okay, of the rhombus, ABL and angle C. All right, now we know in a rhombus or in any parallelogram, the consecutive angles are supplementary. Okay, so those two angles are supplementary. Now we've already said they're congruent. So if they're congruent and they add up to 180, they must both be 90. Okay, so they must be right angles. Congruent supplementary angles are right angles. Okay, so that's how I stated that. Now we have that ABCD is a square. Because it is a rhombus with a right angle, we actually showed two right angles. Okay, so that makes it a square. Okay, now the second one's going to be really short. Okay, um, we have BDG bisects angle ABC. Okay, we have two pairs of parallel sides. Okay, so those are my givens. So that's how I'm going to conclude that ABCD is a parallelogram. Okay, a quadrilateral with two pairs of parallel sides is a parallelogram. Okay, now BDG bisects angle ABC. There it is. Okay, the property of a rhombus. Okay, here it's a parallelogram first, and one pair of opposite angles is bisected by a diagonal. Okay, so that makes a rhombus. Okay, so I just went straight to that. Okay, so since it bisects the angle, ABCD is a rhombus. A parallelogram with a diagonal that bisects the angles is a rhombus. Must be a parallelogram first. Okay, just remember that. Okay, I know they're two quick examples. Okay, see what you can do with these practice problems. Okay, I will give you a couple of hints. Okay, up till now, we haven't really talked about specific measurements of angles. Okay, in this case, you're going to have to state the actual measures of the angles in this proof, not just that they're congruent, 1 and 2, but think about what the actual measures of 1 and 2 must be. Okay, and also, what do you know about the diagonals of a rhombus? We've talked about that many, many times. The diagonals of a rhombus, they should pop right into your head. Okay, and that should help you with that one. Okay, I'm going to give you a hint on the second one also. Okay, there's a little bit different looking diagram. Okay, but we're trying to prove that EBFD is a rhombus. Okay, now E, F, and D are midpoints of the three sides of the triangle. Okay, so those two segments, ED and FD, are mid segments. So remember what we talked about mid-segments of a triangle. Okay, the mid-segment is parallel to the third side. Okay, and the length of a mid-segment is half the